Alright guys, so this is the notes I had planned on giving you on 3D printing. There's not going to be a whole lot of them, and these are going to be pretty short videos. Your learning goals, describe how a 3D printer operates, make a list of the parts of a 3D printer, describe the function of a slicer, and how to create a file for a 3D printer. Um, and these are not, the 3D printer is the thing doing all the work. Really, we just have to tell it what to do. So when we have manufacturing, there are two different types. We have subtractive and additive manufacturing. So in subtractive, what we're doing is we're carving something out of something else. So a wood lathe, which I have a picture of a wood lathe going on here, that'd be a great example of subtractive manufacturing. Um, Something that's a little closer to 3D printing, though, might be um, like a CNC router, where in a CNC router you have to kind of program what the object's going to look like, and then a machine comes in and carves it out of something. This is really helpful when you want to make parts for like an engine or something like that. Additive manufacturing is something that you build up over time by stacking layers. So a 3D printer. And the way a 3D printer works is it just lays down a very thin layer of plastic on top of an older piece of plastic. So for 3D printing and additive manufacturing, we have to have something called fused deposition modeling. So pull up a highlighter here. So what this is we need to have the layers fused together in the 3D printing process. And 3D printers take advantage of this to complete the additive manufacturing process. So the plastic, what we call the filament, has a property that when it gets melted, it will fuse to the other parts that are not melted just underneath of it. Now, not every material is good for fused deposition modeling. There's simply some materials that cannot be used or are extremely hard to use for 3D printing. For example, wood. We can 3D print with wood. What they do is they take wood dust and kind of mix it together with molten plastic and then string it out into a cord. So you can sort of 3D print with wood. A big one right now is metal. We're trying to figure out how to 3D print with metal, and there's machines that can do it. Now, there are pros and cons to both additive and subtractive manufacturing. Subtractive manufacturing it can be very precise, and at the end of the process you get a solid part. You don't have to worry about the layers coming loose or anything like that. But there's a lot of waste. A lot of metals getting flung out here. There's a lot of wood being chiseled away here. In the additive method, there's very little waste. So you can, more of your product is getting turned into something. But because there are these little tiny layers here, it's not going to be quite as strong. And that's where additive manufacturing can have some downsides. It's not quite as strong as subtractive manufacturing. But it's a great place to model something. If you're a scientist wanting to, or an engineer trying to create something, this is a great way to very cheaply create a model to see if something's going to work, and then you can use a different method to manufacture. So 3D printing definitely has its place. I find it very, very fascinating. So once you have made an object, an inventor, and you're ready to 3D print it, we have to kind of convert the file. Right now the file is a .ipt file. So what you can do in Inventor is you want to create what's called an STL file. I'm not going to attempt to pronounce it, but there's what STL means. Um, there, and it's kind of like the most commonly used file for 3D printers. Um, so what Inventor does is it converts it from an IPT to an STL. So the workflow for this, in the top left corner, you want to click on the eye, and you're going to get a drop-down menu, and you want to look where it says Send to 3D Print Service. And once you do that, you're going to get this box right here, and this is what you want to click on right here, Send to 3D Print Service. And you're going to get this box right here pop up. You can see the STL file here. Now, I'm not sure why Inventor does this, but under the scale, you want to go from 1, you want to convert that to 10. There's some sort of, there's something going on where that conversion process, something gets interrupted, but you want to convert it to 10. Then obviously click OK, go through it, you're going to save it, all that stuff. You tell it where to save to. And once you have your STL file, basically any 3D printer will be able to use it to create something. Now, the 3D printer uses some software called a slicer. And what that does is it's going to take your object that you've created and it's going to break it up into a lot of thin layers. It's going to slice it down into thin layers. And that's going to show or direct the 3D printer where to go on a Cartesian coordinate grid to build up your part. Every 3D printer has its own proprietary slicer software. So for us, since we're using a MakerBot printer, MakerBot has its own slicer. This is kind of what it looks like right here. And what's kind of cool about this slicer is I can move where the part is on the table. I can rotate it. I can resize it. I can slide it around. There's a lot of controls with that, which is kind of neat. And this picture right here kind of gives you an idea for what the slicer does. You can see how it breaks the object up into a lot of layers, and it'll tell you how many layers it takes right there. So each 3D printer, again, is going to have its own proprietary slicer software, and you can, so if you buy a 3D printer, it'll come with a disk that you can download that software onto your computer. So basically, there are 3 components that you need for 3D printing. You need some software to make your part. So for us, we've been using Inventor. You need some software to slice it. So again, that comes with your 3D printer, and then you need the 3D printer which physically makes your part. So those are the 3 things you need to get into 3D printing. All right, that will be good for this first round of notes.